Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. We from group 3, we will be presenting our topic here, which is transmission. So this is our group members, consists of 3 people. So first, we will look in our content in our presentation today. So first of all, types of gears and the applications. Second, gear ratios, driven and driving gears, idler gears and backlash. Third, belts and pulleys, chains and sprockets. So first, we have 5 types of gears: spur gears, helical gears, bevel gears, worm gears, and planetary gears. So first of all, spur gears. Spur gears are the simplest type of gear used to transmit motion between parallel shafts. They have straight teeth that are cut parallel to the gear axis. Their main characteristic: easy design, high efficiency, and smooth power transmission at a constant speed. They are commonly used in applications such as clocks, washing machines, gearbox, and other machinery that require simple, reliable motion transfer. So, as the image shown, the spur gears are parallel to each other and they have straight teeth. Second, we have helical gears. Helical gears have teeth that are cut at an angle to the gear axis, forming a helix shape. So, helical gears are commonly used in car transmissions, industrial gearbox, and other machinery that requires high speed and quiet operation. So the difference between spur gears and helical gears, the gears are parallel together, but the teeth they have an angle itself, not straight teeth. So third, we have bevel gears. Bevel gears are gears with conically shaped teeth that are used to transmit motion between shafts that intersect, usually at a right angle. So, at the right angle, we can see that the gears are perpendicularly to each other. They have also straight teeth. So, bevel gears are commonly used in automotive differentials, handles, and mechanical systems where power needs to be redirected at an angle. So, sec- uh, next we have worm gears. Worm gears consist of a screw-like gear called a worm that mesh with tooth wheel known as a worm wheel. They are used they are used to transmit motion between shafts that are at right angles and provide a very high gear reduction ratio. This allows for high torque output with compact size. A key characteristic of worm gears is that they prevent back driving, meaning the worm wheel cannot easily turn the worm. Worm gears are commonly used in elevators, conveyors, tuning instruments, and lifting mechanism. So as the image shown in the slide, the worm gears is basically the metal rod that connect to the gears, and the the teeth they have is not a straight teeth, but they have an angle. So last gears is planetary gears. So planetary gears consists of a central sun gear, and several planet gears, and an outer ring gear. The planet gears rotate around the sun gear while also meshing with the ring gear, allowing power to be shared among multiple gears. This design provides high torque output, compact size, and smooth operation. So planetary gear systems are very efficient and durable, making them ideal for automatic transmission, robotics, and industrial machinery where a space is limited but high performance is needed. So as image shown, we can see that the gear are called the planetary gears because they have the center gear which called the sun, and the planet are called the 3 gears the outside of the sun is the planet's gear, and they have the outer ring. So it's like our solar system. So that's all from me. I will give to my friend to our next topics. Thank you.
Good day, everyone. For my part, I'll be explaining about gear ratios, driven and driving gears, idler gears, and backlash, all of which are important in how power is transmitted through gear systems. Gears work together by transferring motion and torque between rotating shafts, depending on how the gears are arranged. We can control the speed, direction, and power of the output. So let's begin with gear ratios, which basically describe how fast one gear turns compared to another. Understanding this help us see how machines adjust speed and strength for different purposes. So for our next page, a gear ratio is the relationship between the number of teeth on two gears that mesh together. The formula is simple. Gear ratio same as teeth on driven gear plus with teeth on driving gear. What this means is that the ratio tells us how speed and torque are exchanged. If the ratio is greater than 1, that means the driven gear turns slower but produces more torque or more force. If the ratio is less than 1, it means the driven gear spins faster but with less torque. For example, if the driving gear has 20 teeth and the driven gear has 40 teeth, the ratio is 2 and 1. That means the driven gear rotates half as fast, but the torque is double. In real life machines like bicycles or cars, this principle is what allows us to climb hills slowly with more force or move far with less force. So that is, let's look at the driving and driven gear. The driving gear is the one connected to the power source. For example, an electric motor or an engine provides motion to the system. The driving gear is the one that receive motion from the driving gear. When the two gear mesh, they always rotate in opposite directions. This opposite rotation is why when you look at the two mesh gears, one turns clockwise and the other turns counterclockwise. These two gears work as a pair to transmit motion efficiently. Understanding which gear is the driver and which is the driven one helps engineer design system that can control both speed and torque depending on what the machine needs to do. And after that, idler gear. Now, sometimes a third gear is placed between the driving and driven gear, and it is called the idler gear. The main function of this idler gear is to change the direction of rotation, which is the driving and the driven gear. And for example, imagine a three-gear system. For the driving gear turns clockwise, the idler turns counterclockwise, and the driven gear turns clockwise again. This setup is useful when the designer wants the input and output shafts to rotate in the same direction, such as in some mechanical linkages or car transmission. Yes, car transmission. So remember, idler gears are used for direction and not for changing speed or torque. And the last one is, let's talk about backlash, which is the small clearance or gap between the gear teeth. Backlash may sound like a flaw, but it actually serves several important purposes in their design. First, it prevents jamming. If gears fit too tightly together, even a bit of dirt or heat expansion could make them seize up. So the small gap lets them move freely. And second, backlash allows lubrication to stay between the gear teeth. This thin layer of oil reduces friction and prevents wear. Then third, it helps compensate for thermal expansion because gears expand slightly when they heat up during the operation. The gap prevents them from locking together. And finally, backlash helps reduce noise and vibration within limits. A small amount of clearance helps absorb vibrations, but too much backlash can cause knocking sounds or inaccuracy. So, engineers carefully design gears which has the right amount of backlash and to ensure smooth, quiet, and long-lasting operation. In conclusion, understanding these elements, gear ratios, driving and driven gears, idle gears, and backlash is essential to know transmission system work. Each one, um, each one plays a role in balancing speed, torque, direction, and smoothness of operation. Together, they make sure that machines like cars, clocks, and even industrial robots perform efficiently and reliably. Thank you for listening.
Assalamualaikum. My name is Ahmad Zain bin Zainuddin, and I am from Group 3. And I'm going to be presenting a transmission. And my part is belts and pulleys, chains, and sprockets. Okay, first let's talk about belts and pulleys. A belts and pulleys system is a mechanical engagement that uses a continuous flexible belt running over two or more rotational pulleys to transfer power or motion between shafts. The belts connects the driving pulleys and the driven pulley, which receive the motion, allowing smooth and efficient transmission of a mechanical energy, often used in machines, engines, and industrial equipment. These are the main parts. They got three main parts, which include belt, driver pulley, and driven pulley. Uh, the driven pulley is the small one, pushes the bigger one. A belt and pulley system works by using a flexible belt loop around two or more pulleys to transfer motion and power from one shaft to another. When the driven pulley, that one connected to the power source, such as a motor rotates, it moves the belt, which it in turn rotates the driven pulley. This motion allows energy to be transmitted efficiently over a distance. There are four types of belts and pulleys, which include round belt and pulleys, flat belt and pulleys, timing belt and pulleys, and V belt and pulleys. Um, they all got different types and different shapes. The round belt has a circular cross section and runs in a round groove on the pulley. It is flexible and can bend easily around small pulleys, making it suitable for light duty application. And the flat one is the simplest types of belt drivers. It has a flat section and runs on flat pulleys. The belt the belt transmitted power through frictional contact between the belt and the pulley surface. Uh, for the flat belts are commonly used where high speed and low power transmission is required. The next one is the V belt and pulleys. The V belt has a trapezoidal V-shaped section that fits tightly into the matching V groove of a pulley. This design increases the frictional grip between the belt and the pulley, allowing greater power transmitted without slippage. And lastly is the timing belt and pulley. The timing belt, also known as a toothed belt or synchronous belt, has a teeth on its inner surface that fit precisely into matching grooves on the pulley. This ensures that the belt and pulley rotates in perfect synchronization, eliminating slippage completely. Timing belts are used in application where accurate timing is crucial, such as car engines. And the next one is chain and sprockets. There's a difference between chain and sprocket and belts and pulleys. So for higher power transmission, people tend to use chains and sprocket because they can handle heavy loaded and high torque, no slippage, and durability under harsh condition. That's chain and sprocket. Other than that, chain and sprockets has a precise speed ratio, good for machinery that needs exact timing or speed control, like engines or bicycles. Other than that, belts and pulleys are better for a quiet operation because belts run smoothly and make less noise, perfect for home appliance or machines in quiet environment. Long distance power transmission belt can contact shaft that are far apart easily, and it is low maintenance. Let's talk about chain and sprockets. Chain and sprocket system is a type of mechanical power transmission that uses a metal chain and toothed wheels called sprocket to transfer motion and power between two or more rotating shafts. The chain consists of a series of interconnected metal links that fit precisely into the teeth of the sprockets. These are the picture of the sprockets. There are three main parts, which is chain, driver sprocket, and driven sprocket. As usual, the driver sprocket always be gonna be the small one, just like so. Uh, a, a chain A chain and sprocket system works by using a continuous metal chain that loops around two or more toothed sprockets. When the driving sprocket is connected to a power source such as an engine or a motor begins to rotate its teeth, engaged with the link of the chain. This engagement pulls the chain forward, causing the driven sprockets to rotate at the same speed ratio. There are actually five types of chain sprocket, but I'm listing only four. The roller chain sprockets, a silent chain sprocket, conveyors chain sprocket, and lastly the leaf chain sprocket. Um, these are the picture. Each one have the different types and the different toothed edge. So let's talk about the roller chain sprocket first. Roller chain sprocket is the most common type used in power transmission system. It consists of a series of cylinder rollers connected by a side links. It roller fits the roller fits perfectly into the teeth of the sprockets, reducing friction and wear during motion. This type is widely used in bicycles. That is the roller sprocket is the commonly used, and we all usually see this type of sprocket. The silent chain and sprocket. The silent chain and sprocket is called an inverted tooth chain. Has teeth shapes links that engage smoothly with the sprocket teeth. Unlike roller chain, these chains runs more quietly and can handle higher speed and heavier loads. They are often found in automotive engines, timing drive, and industrial machines, where quiet, precise, and powerful transmission is needed. The next one is leaf chain and sprockets. The leaf chain, also called a lifting chain, is made by stacking multiple metal links plates together, connected by pins. It does not have roller or teeth. This design makes it very strong and suitable for lifting and load being application such as for lifts, cranes, and the haze. Lastly, conveyor chain and sprockets. A conveyor chain and sprocket is designed specifically for a material handling system. It can have attachments, extended pins, and a roller to carry items along the path. These chains are used in factory conveyors, packaging lines, and assembly system. They move at slower speeds, but they are built to be sturdy, reliable, and customizable for different industry uses. That's all from me. Uh, Thank you.